Hello everyone and welcome to our YouTube channel. We are working on a series of videos on openmp and this is our seventh video in the series. If you haven't checked out the previous videos, do check them out to get better context and idea of openmp. In the previous video, we talked about sections construct, and in this video, we'll be talking about the single construct. Okay, so a single construct, what does it mean? Single construct ensures that a single block is executed by only one thread. So what I mean to say by that is, when I write the command pragma on parallel, a multiple number of threads are created by it. But whenever a single construct is encountered, only one thread is allowed to pass and execute the block. Rest all the threads skip that block and encounter another barrier and wait for that thread to finish its execution. You will get a better idea of it when we move to the live demo. So let's look at the program. So we have pragma on parallel. So what this does is it creates a number of threads that will be executed in parallel. So, and then I'm doing int tid. So this is an omp get thread num. So what this will do is get me the thread ID. So the number of the thread. And printf, and this part will tell me how many threads were generated by the pragma omp parallel. Why am I doing this? Because it's to show you how omp single actually works. So what it will do is it will tell me how many threads were created, and then I've put a pragma omp single statement, after which I've put another print statement. So it will tell me how many threads executed this printf, single executed by thread printf. So let's look at the live demo. Yeah, I am connected to a HPC Paramrudra, and inside that I am in the login node right now in the openmp programs directory. And in this node, I have currently noded the Intel Valve API compilers, which is required for openmp execution. So I'll show you the code once more. This is the program that will be compiling. It's the same program as in the PPT. So let's get to it. I'll just compile the program. G++, then open mp underscore single. That's the file name. I think there are too many singles, so f openmp. Oh, that's a typo. I have a small p in single. Okay, now the program is compiled and we can run the executable file. Okay, so up until this parallel part by thread. Okay, so here is the single part here. So what happened here? You might be asking, why is that the parallel part were executed later, single part later? Single part was executed first, even though it was written after that. Like I explained before, whichever thread finishes first, it will simply produce the output. So in this program, there is no limitation on the threads in this part. They are doing the work and they will continue to do the work until they finish. But in the second part, so that's the omp single part, there is a limitation. Only one thread can pass through. Rest all have to wait for this thread to finish. So what happened? So as you can see, parallel part was the first thread to complete the parallel part. Hence, as soon as it completed it, it passed on to the next one, which is the single executed thread, pragma omp single, and it uh, executed the this printf statement, and rest all the other threads, which were slower than thread 18, just did the parallel part and nothing else. If we run the program again, yeah, now the single part was executed by thread 16 because thread 16 was the fastest. So you can see whichever thread was the fastest went into the passed into op single first, and then it was left to do, and it was left to execute this thing while the other threads waited for it to finish. And this is it for this video. In the next video, we'll be talking about some other construct. Thank you.